Hi everyone. So today what we're going to talk about is some basic differentiation rules, some simple rules that you can use to find derivatives. So up until now, you've probably been finding derivatives using the limit definition of a derivative or taking the limit of the difference quotient, which is really long and tedious, and it gets really complicated once your functions start getting more complicated. So now you can kind of breathe a sigh of relief. We're going to talk about some rules that you can use instead of using that limit process. Okay, so why don't we just get started then? So the first rule we're going to talk about is the constant rule. So whenever we have a function that looks like f of x equaling c, which is just a number basically. So whenever you have a f of x equaling a regular number, like this example down here, f of x equaling 7, when you take your derivative, f prime of x, it's just going to be equal to 0. So in other words, the derivative of any number is just 0. And you can think of it because the derivative is a rate of change. If your function is just always one number, you're never changing anything, so your rate of change is 0. That means your derivative is 0. Okay, so let's find the derivative of f of x equaling 7. Well, using the constant rule, we know that the derivative of a constant is always 0. It can be 7, it could be a million, it could be a trillion, 999 billion, whatever you want it to be. It could be a really big number, a really small number, it could be a negative number, a fraction, anything like that. The derivative of a constant, always 0. So really important to remember. Our next rule, which is the one that's probably the most important rule out of everything that we're going to talk about today, is what we call the power rule of differentiation. So you're going to use this in almost every single derivative problem that you do. So the power rule says that if we have a function, so f of x equaling x to the n, where n's a number, so we have x raised to a power. All our derivative is going to be, our f prime of x, is you're going to bring down this n, make it a coefficient, so you're going to have n times x, and then you're going to subtract 1 from your exponent. So that's always it. So some basic steps to going about using the power rule when you're taking derivatives. Sometimes it's really straightforward, you don't have to do anything. But your first step is to always rewrite your function. So rewrite function, so your function f of x to be in that form of x to the n, which, because this is an important step to do because sometimes you have like a square root or anything like that. You want to rewrite the square root to be x to the power of 1/2 because that's going to make taking the derivative a whole heck of a lot easier. So you always want to rewrite that, and then you just want to apply your power rule. So apply your power rule. And your third step, just simplify if you can. Maybe simplify and make it prettier, easier to read or use. Okay, so we're going to apply those 3 basic steps to these next 3 little example problems. So we're going to find the derivative of each of these 3 functions. Okay, f of x equaling x. Well, there's technically a little 1 exponent here, so we have a power of 1. So our derivative, our f prime of x, applying our power rule, is going to be 1 times x to the 1 minus 1 power, which is just going to be 1 times x to the 0 power. And anything raised to the 0 power is always 1, so we get 1 times 1, or 1. Which, that's a constant function. You might be saying, Hillary, why is that a constant function? Well, think about this, f of x equaling x. That's really just the line y equaling x, which has a slope of 1. So whenever you have a line, you have a constant slope, which means that your derivative should always be the same number, or the slope of your line. So that's why we just get a 1 there at the bottom. Okay, so for over here, f of x equaling the square root of x, that makes things a little hard. It's not already written in a form that we can apply our power rule in. So let's first do that first step of rewriting. So let's have f of x, and we just said on the previous slide that the square root of x is the same thing as writing x to the 1/2 power. So now we can do step number 2. We can apply our power rule. So power rule, bring down the exponent, make it a coefficient, so we get a 1/2 times x to the 1/2 minus 1 power, which is just going to be 1/2 times x. 1/2 minus 1 is the same thing as 1/2 minus 2 over 2, which is 1/2 times x to the negative 1/2, which, if we rewrite it so we don't have any negative exponents, this could be considered our step 3 of simplifying. we get 1 over 2 times x to the positive 1/2, which is just 1 over 2 square root of x. So stopping here at this line, that's also acceptable. That's a fine derivative for you to write as your answer. But if you want to take it a few steps further, make it a little easier for you to understand what your function really is, you might want to take it down to this bottom, or at least rewrite it so you no longer have any negative exponents. Okay, so last one on the page. So let's again rewrite our function over here. So f of x equaling 1 over x. That's the same thing as saying x to the negative first power. Those negative exponents bring things into the opposite side of a fraction. Okay, so now we're ready for step 2, applying our power rule. So we get f prime of x equals negative 1 times x to the negative 1 minus 1 power. Simplifying, we get negative x to the negative 2 power, which again, if we want to take it to step 3 and simplify, we're just going to get negative 1 over x squared. So easy as that. So doing problems like these before, when we were using the limit-taking process for a derivative, it would have taken us a really long time, especially for these last two problems. The first one, f of x equaling x, that probably wouldn't have taken too long. But those other two, those are complicated. They would take a long time. With these different differentiation rules, problems are going to be a lot quicker for you. Okay, so just like in that last video when we were talking all about finding the equation of the line tangent to different functions, we're going to do that now and show you how much faster it is to do it with these differentiation rules. Okay, so we said that when we find the equation of the tangent line, we need two things. We need m, our slope, and 2, we need our b, our y-intercept. So to find our slope, we need our derivative. So slope, or derivative, of this function is applying our power rule. We're going to bring down that 2, make it a coefficient, x to the 2 minus 1 power, which is 2x to the first power, or just 2x. So we know our x-coordinate is negative 4, so our slope is just going to be f prime of negative 4, which is 2 times negative 4, or negative 8. So in order to plug into our point slope form, or that y minus y1 equals slope times x minus x1, we should plug that negative 4 into our original function and find our y-coordinate. So when we do that, we do f of negative 4, so we get negative 4 squared, which is positive 16. So now we can plug into this. So we get y minus 16 equals negative 8 times x minus negative 4, or plus 4. So when we simplify, we get y minus 16 equals negative 8x minus 32. Add 16 to both sides to get that y equals mx plus b form. We're going to get y is equal to negative 8x minus 16. So that was a whole heck of a lot faster than the problems were taking us last time when we're taking the limit of the difference quotient. I only had to extend the page once rather than doing it 3 or 4 times. It was a lot faster. Okay, so now let's go over a few more differentiation rules that you might need. So when you have a function that's of the form c times some other function, say g of x. So an example for this would be like these functions down here, or another one might be if your f of x was equal to something like 2x. All it is your derivative then, your f prime of x, is just going to be equal to that constant that's outside times the derivative of the function. So like for this one, we know that the derivative of the function x is just 1. So our derivative here would just be 2 times 1, or 2. So we're going to use that rule a lot as well. Okay, so let's try out these two example problems here at the bottom. So 4x squared all over 5. That looks a little complicated right now because we have a denominator, but what we can do is we can rewrite this function to just be the same thing as 4/5 times x squared, because that's the same thing, right? Because 4/5 times x squared, you would just put the x squared up in the numerator. So now we can apply our power rule and our constant multiple rule. So our constant is going to stay the same, so we'll do 4/5, do parentheses, and then take the derivative of this x squared term. So now we're going to use that power rule, bring down the 2, make it a coefficient, 2 times x to the 2 minus 1. So we're going to get 4/5 times 2x, which is just going to be 8x over 5. Simple enough. Okay, let's try the next one. So just like we were doing before, we need to rewrite this function in order to make it a little easier for us. So let's bring out that x out of the denominator with a -1 exponent. And now we're ready to apply our constant multiple rule and our power rule. So we're going to get 2 times, bring down that coefficient, exponent as a coefficient, -1 times x to the -1 minus 1 power. We're going to get 2 times -1 x to the -2, which is just going to turn into -2 x to the -2, or if you simplify, -2 over x squared. So these problems take a lot less time when you're using these rules, and you definitely want to have them memorized. They're going to help you out when problems start getting more complicated. Okay, so now we have the sum and difference rule. So say we have this function h of x, and all it is f of x plus or minus, works for either operation of addition or subtraction, another function g of x. If we take the derivative of h of x, or h prime of x, all it is it's going to be the derivative of f plus or minus the derivative of g. So in other words, all this means is if you have a bunch of different terms, if you're taking the derivative of a polynomial function, all you do is you take the derivative of each part of it and then you add or subtract them together depending on what the signs are in between them to start off with. So let's see how that works. So we have f of x equaling x cubed minus 4x plus 5. Put on that exponent of +1 here just to make our power rule a little easier when we get there. So we're going to f prime of x equals applying our power rule to first the x cubed. We're going to bring down that 3 times x to the 3 minus 1 power. Minus, okay, we have a coefficient here, so we're going to bring in that constant multiple rule. So minus 4 times, bring down the 1 times x to the 1 minus 1 power. And bring in our constant rule from the first slide. Derivative of 5 is always 0, so put a 0 there. We're going to get 3. X, 3 minus 1 is 2, so 3x squared minus 4 times x to the 0 power is just 1, so we're just going to get a 1 here plus 0. So our final answer is going to be 3x squared minus 4. Okay, all done, good to go. So let's move on to problem 2. First, let's rewrite this function because we got some roots going on. We got rational functions, x is in the denominator. That all needs to get rewritten in order to apply our power rule. All these problems generally come back to just applying the power rule after you rewrite. So we're going to have 4. Now the cube root of x squared can be written as x to the 2/3 power. If you need a refresher on fractional exponents, you should definitely go talk to your professor or a classmate or anything about that because that's going to be really helpful for future problems. Minus, and bringing that x cubed out of the denominator will make that x to the -3. Okay, so now let's just go through and apply the different rules we've talked about so far. So we have f prime of x equals 4 times 2/3 to x to the 2/3 minus 1, which I'm just going to go ahead and write as minus 3 over 3. Under parentheses minus 6 times -3 x to the -3 minus 1 power. Okay, so let's just simplify and rewrite. So we have 4 times 2/3. 2/3 minus 3/3 is going to be -1/3. Minus 6 times -3 to x to the -4. Okay? So if we simplify now, we're going to 8/3 x to the -1/3 plus 18 x to the -4. We might want to rewrite those just to get rid of our negative exponents to make things a little prettier. So we're going to get 8 over 3 cube root of x, that's what that 1/3 power means, plus 18 over x to the 4th. There you go. That's your derivative. Simple as that. So I think we have one more slide to go over here, and these are derivatives of sine and cosine. So the derivatives of sine and cosine are something that you really need to have memorized. They're going to come into play a lot for all the other trig functions and anything like that. So our derivative of sine of x, which you might have seen your professor write g dx, to stand for derivative of the sine of x, that's just equal to the cosine function. So the derivative of the sine is equal to the cosine. And then we have our derivative of the cosine, Now you might just be guessing, okay, since the derivative of sine was cosine, the derivative of cosine must be sine, which you're partially correct. It's just going to be the negative sine of x. So when you learn the rest of the derivatives of the trig functions, you might notice the pattern that if the trig function starts with a c, like cosine, cotangent, or cosecant, they're going to have negative derivatives. So that's something that's really important to remember. Derivative of cosine is negative sine. Okay, so let's do this function down here, and then we're all done with this video. So rewriting first, because sine of x over 2, that looks a little complicated. Let's make it f of x equals 1/2 times the sine of x minus the cosine of x. And now we're all ready to apply our derivative rules. So we're going to do f prime of x. 1/2 is just a coefficient, so we're just going to leave it outside. Multiply by the derivative of the sine of x, which looking up is cosine of x, minus the derivative of the cosine of x. So minus the sine of x. So simplifying, we're going to get f prime of x equals 1/2 times the cosine of x plus sine of x. Awesome. So that's everything I have for you today. I hope these basic differentiation rules help you out, make your problems go a little bit faster on your homework. And these are definitely things that you want to start memorizing and getting stuck into your brain, because we're going to start talking about harder and harder differentiation rules that go back to what these rules are. So knowing your basics is going to help you a lot when we get to the more complicated stuff. Okay, thank you so much for watching. Have a great rest of your day.